Alright, y'all, here I am just seconds after finishing the first video, and yeah, the set logic was actually not all that terribly off. That's where I should have been approaching again. So let's go ahead and pick up where we left off, and we'll actually abolish the entire structure of the histogram. So what I'm going to do here is I'll make kind of the semi-longer version just to kind of test our functionality out first. And then after that, we can go ahead and start code golfing it and condensing it quite nicely. So what we're going to do here is I'm actually going to make a set of unique characters here. So a set needs some kind of iterable provided to it for its initial arguments, and a string is also iterable, and we can spread out a string into an array of characters, which is fine and dandy for the set. So this gives us an array of unique characters. So I was kind of barking up the wrong path last time, where I was like, well, I want to do this, but I can't because I need to keep track of the characters and how many times they've been found. No. This is just going to let me know like which characters are in here, and I need to find the first index of each character and the last index of each character in the initial string. And if those two match up, that means it's only found once in the string, and that's all we need. And I'm so mad because I circled around this kind of thought so much initially, and then I shied away from it for a much longer solution. So let's go ahead and just kind of see step by step what we're getting. So this should be a set with 19487 0 in it. And so we're just going to have a set of just unique values. And if you want to, we can actually convert this back to an array. Since a set is iterable itself, we can use the spread operator on it to convert it back into an array. So this is really great because this is a trick you can employ in code golf. If you need an array of unique values, you take your iterable that you spread out into a new set that you spread out into a new array, and that gives you your array of unique values. So, and unique values is kind of a misnomer here. This is all values that, you know, are going to be uniquely place in the set. So it's going to say like, oh, if one's already present, we're only going to keep one in there, you know, once. So it's not, you know, quite what we're looking for solution wise, but it is a start at just letting us know which individual characters we have. Let's see. Maybe I don't need to spread out the string. Okay, there we go. So this is letting us know just the total amount of unique, or the total unique characters here, not like the count, not whether or not they've been found one or more times. This is just every instance of, you know, a character. It says, hey, if it's been found at least once, we place it here in this set. So this lets us know just like what characters we have. And then from here, what we can do is we still have our initial array here. And we can use that for some index of. So like I can say like first, or let's see. We'll do that kind of for loop structure we did in the first attempt at this. So for every character that we have, what am I doing? So we need to take our string, convert it into an array, and execute last index of the current character. And we could do something like find index, but I think index of is a little bit shorter than that. And so index of is just going to return the first index. So if these two don't match up, that means that this is found in at least two different spots in that array of characters, and therefore it's not unique. But if it is found in multiple spots, if last index does not equal, or sorry, if last index does equal first index, then uniques.push character. And so uniques is going to be an unsorted array here of all the characters that are uniquely found. So 7 and 0 are the only characters that are not repeated in that test string. So let's go verify. 1 is found also there. 9 is also found there. 4 is also found here. 8 is also found here. 7 is not found anywhere else. 1 is found in the beginning. 0 is found nowhere else. 4, 9, and 8 all found in the beginning. So 7 and 0 are truly the unique values here. And I wonder if there's a way to do kind of an inline sort here, but we'll just call the sort function as is. And I'll just do the sort reverse 0 and get our answer here. So that's just kind of our quick way with the set. But if we remember like the initial solution with the histograms, that was like 500 something characters before minimization. This is 324. And a lot of this, I think I can do some inline work with. Let's see. All right, so we have our function argument here. I'm going to call this, let's see, uniques. I'll just call it A for array. We define that there. Got our string here. I'm not going to save this to a variable because here I'm just going to set this up as a loop. We've already got the variable declared there. So we've got this. That's now iterable. We'll map over it for every, we'll filter over this. Oh, and if we are doing filter, I guess we don't necessarily need that array quite yet. But let's keep on looking. So we still want this logic here. We'll condense it a whole lot more. But the nice part about filter is we can just return this as a condition. And so this is actually going to be our unsorted array. So let's save this to a variable, make sure I haven't missed anything. Cool, okay. That's condensing a lot. I want to get this to like an inline return. So we could shorten these to other variables, but that's also lots of space that we don't need. And instead, since we're just comparing the results of this to that, we can just put these inline here, get rid of the declarations. Double equals comparison, we're just doing a loose value comparison. And since all we have in our filter here is this return statement, we can just use the fat arrow function for an implicit return. Oh yeah, this is starting to get real nice. We're going to replace string str with just s. I'm not pushing anything to an array because we actually have all of our data here. So we can actually get rid of this argument thus far. Let's see, I deleted a parenthesis somewhere down here. Character is getting replaced with C. And then here, we can just go ahead and do that sort. And it sucks. But that sort reverse index position 0 is still going to be 20 characters. I don't really see how I can shorten that up too terribly much. But yeah, let's see what that's like. And with this all being an inline expression, we can actually just have it be an implicit return from our arrow function. So that's going to be super, super, super consolidated. And it looks like this is all working the way we expect it. Excellent. So let's ditch the curly braces here, ditch the assignment to a variable. These array methods do occupy a lot of space name-wise, like filter, last index of, sort, reverse. We're only using each one of those 5 methods once, unfortunately, because if we use them multiple times, we could reassign some function as, you know, a one-letter variable name function expression that just copies like array.last index of, and that would be a good time saver. But here, I mean, all of these are 5 different unique functions, and I don't think there's any place where I could also spreading out s into an array. Can I call index of and last index of on a string? Yell at me through your monitors if I can or can't. We're about to find out, but no shit. What about last index of? No kidding. Okay, this is really nice because that is a good chunk of space saved. Okay. That was like 10 characters that I cut down on, which could it be actually be like a tenth of this program. Let me go ahead, ditch all the white space, and I think that's all the minimization we can do. And let's see, that comes in at 82 characters. Okay, not quite cutting in half our previous best solution, but pretty dang close to it. And not gonna lie, 82 characters, I'm pretty happy with that. I'm not really a great code golfer, but if I can get something in under 100, usually speaking, I'm pretty happy. Let's go ahead and just double check these solutions though, just to make sure I didn't break it and it's not working. And I got excited for nothing. So this should return 7. Cool. Should return 9. Cool. This one 5. This next one should be undefined. Cool. This one should be 0, and at that point, you know, it's all pretty predictable behavior. You can just like read out the string and see what each one's going to do, but I think it is safe to call this a successful golf. Ah, yes, okay. So we went from this, which, not gonna lie, like, that's not too terrible code, golf, but you know, we did come pretty close to cutting in half with this, so I'm very happy with that solution. But yeah, so I hate that I circled around the initial solution, or this solution so much in the initial video, but here we are in a much more concise, consolidated format, so really happy about that. So yeah, I hope you enjoyed this second part, seeing me virtually, you know, pull my hair out at being so close yet so far in video 1. But if you have a greater solution, whether it's JavaScript or otherwise, please drop those in the comments, because I would love to read those and see what you've done. Anyway, I'll catch y'all in some subsequent videos. See y'all later.